everyone, my name is Liu Peizi. I'm CEO from Ideas Group. These all are my members, which is Tikashini, Maisara, and Oma. Our aim is to produce sugar from sugarcane. Now I would like to pass to Tikashini to proceed her introduction.
Introduction. The raw material that was used by our company to produce sugar is sugarcane. The final requirement is to produce 100 tons of sugar per year. In our previous video, we have stated that we use 6 different unit operations to produce the thick solution. Now, we have added 4 new unit operations, which are crystallizer, separator, dryer, and finally storage to produce the sugar. Our final aim is to run a very successful sugar industry. Crystallizer. The function of the crystallizer is to boil the thick solution from the evaporator at a low temperature with seeding to induce the formation of crystals. The seeding technique that was used is to scratch or scrape the walls of the crystallizer to induce the formation of crystals through crystallization. The crystallizer that was used in our plant is the pilot plant crystallizer. The price of the crystallizer is 4,430 ringgit. The crystallizer has 1 input stream and 2 output streams. The output streams consist of the massicute and the water. The massicute is actually a combination of the molasses and the raw sugar. This massicute will then pass through the next unit operation until it forms the final sugar.
Boiler. The boiler we use is bagasse fire boiler. The function of the boiler is to burn the bagasse as biomass fuel to produce steam. The steam will then supply to evaporator depends on the specification of evaporator set. The waste products also produce, which is flue gas. The flue gas will then transfer to heat exchanger to heat up the air from 25 degrees Celsius to 70 degrees Celsius to supply the hot air dryer. M2, M7, and M10 are the streams from the bagasse. The bagasse total production is 37 kilo per hour. So, from the equation, we can calculate that the feed water to bagasse is 2:1 ratio. Therefore, the feed water required is 74 kg per hour. Next, the steam production ratio to bagasse is 2.2:1. Therefore, 81 kilo per hour of the steam will produce from the 37 kilo per hour of the bagasse. So, the steam required for evaporator only 70.54 kg per hour. Therefore, we have the excess steam to sell out and we can earn for the income. There are the heat loss from flue gas which can calculate for the mass of the flue gas. This is the equation. The heat loss of flue gas percent is 7.92%. Therefore, the mass of flue gas produced is 74 kilo per hour. This is the equation of the gross calorie value of the bagasse, which is 188,060 kJ per hour.
Heat exchanger. A heat exchanger is a device that allows heat from a fluid, a liquid or a gas to pass to a second fluid, another liquid or a gas, without the two fluids having to mix together or come into direct contact. Here the Q value of flue gas is equal to Q value of air. Here we get the Q value in kilowatt is -9360. In heat exchanger we have 2 input and 2 output. It was the exothermic process because the Q value is negative. The air at the room temperature passed through the heat exchanger and the flue gas produced from boiler at 230 degrees Celsius will heat up the air to 70 degrees Celsius. The 70 degrees Celsius air will supply to air dryer in drying processing.
Separator. Separator is a centrifuge is used to separate the sugar crystal from the molasses. Almost 14% of inlet stream is molasses, as a composition of 0.2 water, 0.35 sucrose, 0.12 reducing sugar, and 0.2 soluble impurities. There are 2 outlet streams for the molasses and the other for the moisture sugar crystals. After energy balance calculations, it's found that the total heat energy is almost negative 3000 kilowatt at temperature 38 Celsius. And for the dryer, is used to dry the moisture sugar crystals after separation process. In addition, this process is beneficial in preventing the sugar lumps during the storage. Almost 99% of the water content in the inlet stream is removed after the drying process. This type of the dryer is hot air dryer. The air inlet, which comes from the heat exchanger, and the outlet temperature of air is 70 Celsius. The sucrose recovery is almost 70%, and the purity is almost 98%. After energy balance calculations, it's found that the total heat energy is almost 700 kilowatt at 70 Celsius and 6 bar.
Now come to our net energy calculation. We already summary up in the table, and we can see that our process is endothermic reaction, and we produce a lot of heat, which is 207,838 kilojoule per hour. This is due to the boiler. During the burning of the bagasse, it produces a lot of heat, which is 224,892 kJ per hour. Now come to our costing. Our total investment required is 333,316 ringgit, while our total cost of operation is 190,528 ringgit. After the calculation of the cash flow, we can see that our production rate of the raw sugar per year is 99.4 ton. For molasses from separator is 6.36 ton, and the steam after supply to the evaporator and in excess is 11.05 ton per year. So after we sell the three products, we can get back the total is 255,926 ringgit. In 20 years back, we can get back 887,363 ringgit. From the graph, after second year, we can see that our graph is increased linearly, and our cashback period is between 6 to 7 years. Our cashback period is quite slow because of the cost of equipment and the low production rate. I believe that in the future, our company will expand to big scale company and success in the future. In summary, our raw sugar obtained is 12.55 kg per hour, and the purity of the sugar is 97.97%, while the recovery of the sugar is 69.5%. We almost achieved the target which provided by the instructor, which is 100 ton per year. We can get 99.6 ton per year. So I believe that in the future we can do better and we can learn a lot. That's all from us. Thank you.